All right, lesson 4 on theoretical probability. So theoretical probability, we spoke about experimental, how you perform the experiment. We have 3 definitions here of what an experiment, sample space, and event space are, which we went through during lesson 3. I'll quickly read over them again. So an experiment is a well-defined process from which observations can be made. The process being rolling a die or a deck of cards, tossing a coin, and your sample space are all the possible outcomes of an experiment. So we use S, and I wrote here U for universal as well. You have the universal set or the sample space. S is used to represent the sample space. For example, rolling a die, your possible outcomes, your possible samples are 1, 2, 3, 4, 5, 6, the 6 sides to a die. An event space, a collection of a group of outcomes from S. Remember, S, we use S or U, universal set. Capital letters, excluding S, are used to represent an event set. It contains the specific outcomes you are interested in. If you are trying to find the probability of rolling an even number with a die, then the experiment is rolling the die. Your sample space would be 1, 2, 3, 4, 5, 6. It has all the possible outcomes. And the event space, because I'm specifically looking at even numbers, is 2, 4, or 6. So a simple event is an event that consists of only one outcome. The probability of an event is a number between 0 and 1. And the problem with experimental probability is it's tedious. I gave you the data sets for the previous lesson, but it becomes tedious tossing a coin 50 times over, rolling a die, and looking at spinners, etc. All of that becomes tedious, even though we have a lot of online programs that can help us with that. Performing the experiment, recording the data, making sure you're accurate without making mistakes, all becomes a bit tedious to do. So, theoretical probability can be applied to situations which can be modeled by mathematically fair objects such as coins, dice, cards, spinners, etc. Assuming that all outcomes are equally likely, the theoretical probability is calculated using the formula. The probability of A is the number of times A has occurred over the sample space, the number of outcomes in the sample space. And all theoretical probabilities must lie between 0, which is impossible, and 1, which is certain. Just a reminder back to complementary events. So the complement of set A is A naught. So that little tick at the top there means A naught. It's basically everything that's not in A. It refers to all outcomes in a sample space that are not in the set A. The probability of a complementary event is found using the formula P, and then we have A naught is equal to 1 minus P at A. It's pretty straightforward, logical thinking. If I have an event, the probability of it not happening is 1 minus the event of it happening. So for example, if I'm talking about basketball, let's use basketball. And if I have a 60% chance of making a basket, then the probability of not making that basket, so A naught, would be 1 minus 0.6 as a decimal. The probability of not making a basket is 0.4, which is 40%. So 40% not making a basket. Okay, so that's a complementary event. So we're going to look through a few examples here. You're going to want to get familiar with a die or a set of dice. You want to get familiar with what prime numbers are. You'll also, maybe I'll post as well, have a visual of what a set of deck of cards looks like, because you're going to have to get familiar with that as well. So let's start with a single die, has 6 sides, and a single die is rolled. So determine the probability of rolling each of the following. So remember, the set of die or your dice, your sample space would be 1, 2, 3, 4, 5, 6. I have 6 sides to my dice. The probability of rolling a 5, if I look at my sample space, is 1/5. Oh, sorry, 1/6. 1/6. I have 6 sides. Therefore, the probability is 6. The probability of an even number out of those numbers on my die, the even numbers are 2, 4, and 6. So my probability would be 3 out of 6. And if I reduce that, it'd be 1/2. The probability of not a prime number, so not prime, would be 1, 4, 6. You want to get familiar with what prime it means and what are prime numbers. These are not prime numbers, 1, 4, and 6. Therefore, I have 3 outcomes out of 6, which also reduces to 1/2. I will post a spread or a visual of a deck of cards, but just to do this here in words the side so you have it for the note. A deck of cards is assumed to have 52 cards. That's without the jokers. When I say deck of cards, I mean without the jokers. You want to be familiar with the suits. You have 4 suits. You have hearts, diamonds, you have spades, and clubs. We also have 2 suits that are red, because you want to be familiar with the colors of red and black. That is hearts and diamonds. And you have 2 suits that are black, and that would be spades, spades. Oh, I didn't want to write that all out. Spades and clubs. And then each suit, there's lots of little pieces of information here and ways we can ask about probability in cards. You have 2 to 10 numbers. Sorry, 2 at 10 numbers. You have Jack, Queen, King that are faces. Okay, so those have faces. The card that's an ace is not considered a face. And 2 jokers, not normally included. If it was included, you would have 54. Okay, so that's not normally included. So that's there on the side. I'll post a visual for you guys to help. So the probability of drawing a red card would be half, right? We have red, half the deck is red, half the deck is black. So the probability of drawing a red card would be 26 out of 52, which is 1/2. The probability of a club. I have 4 suits. 13 of them are clubs out of the 52. So that would be a 1/4 probability. You have 4 kings and you have 4 suits. So therefore, 4 kings, 1 of each suit, meaning there are 4 kings out of the 52 cards in your deck. So those are pretty straightforward there. The king of clubs. So you have 4 kings, 1 of each suit. So therefore I have 1 king of clubs out of 52. The probability of not a heart. There are 2 ways you can do this. Either way is okay, but if I think of, I have 13 diamonds, I have 13 spades, and I have 13 clubs in total. And I'm not including the hearts because it wants a not heart. So basically heart complement, heart not. Would be 39. If I add them all up, 13 plus 13 plus 13 would be 39 out of 52, which is 3/4. If you wanted to do it the complement way, so probability of not. It's a heart in there. That should be a heart. In case you can't see that, that's my heart. Would be 1, which is the whole, minus the hearts, which is 13 out of 52. I have 13 hearts out of my 52 cards. So 1, which is my whole, minus 13 over 52. You need to find a common denominator. And you end up with the same answer there. Either way is fine. And then not a face card. So I have the probability of F not a face card. I'm going to do this, the 1 minus the probability of a face. So 1 minus the probability of a face. I have 12 of those out of 52. Remember, Jack, Queen, and King are all face cards. So I have 4 of each, 4, 8, 12. The ace is not a face card. Subtracting fractions. Common denominator. And I'm ending up with 40 out of 52, which it reduces to 10 over 13. You should always reduce if you can to make sure you get full marks. Okay, so you'll see there'll be a lot of questions involving cards throughout this course. So get familiar with that and what the cards look like in a deck of cards. Marbles. We have a bag containing 4 red, 6 blue, and 2 yellow marbles. 1 is taken randomly, so I'm just taking a marble out of a bag. What is the probability that the marble is yellow? So in total, so I have 4, I have multiple pieces here. My total amount of marbles would be 4 plus 6 plus 2, which is 12 in total. Okay, so you need to know that total amount because you want to think of your theoretical probability formula from the first page of this lesson. So 2 of the marbles are yellow. So my probability of drawing a yellow would be 2 out of 12, which would be 1/6. The probability of not a red. So I'm looking at 6 blue and 2 yellow. So in total I have 8 possible outcomes out of the 12, which will reduce to 2/3. And a blue, let me see if I can change the color here. Blue, so I have a blue here, and or a red would be 10 out of the 12, which is 5/6. So that is the marbles. And the last one are rolling 2 dice. So for some reason my chart didn't appear in that note there, but here I have 2 dice. I have dice 1, which are the columns, and I have dice 2. Again, this is a good, these are the rows. It's a good chart to have to visualize. Sometimes when you're thinking of multiple numbers and rolling a dice, it's hard to visualize all the outcomes, of course. So if I look at this chart, which is nicely laid out, if I roll 2 dice, there is a possibility, one possible outcome would be rolling a 1 and a 1, which is indicated here in the first row. Okay, so that shows the possibilities. So the total number of outcomes, I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 times 6, I have 36 possible outcomes. Looking at that chart. the probability of getting at least 1/6. So when I say at least 1/6, I'm looking at one or more. So if I look through this, this would be a possibility, 6 and 1, 6, 2, that one, this has a 6, 6. These all, the ones that I'm check marking here, all have a 6 within the outcome. So if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I can roll at least 1, 6, 11 out of my 36 outcome times. That's the probability of at least 1 6 being rolled. And again, this is theoretically. So in theory, this should happen. If I perform the experiment, I'm most likely going to have a different outcome, but it should get close to the theoretical probability the more times I repeat it. And the probability of getting a pair of numbers, so that means a pair, I'm looking at double of the same number. So here I'm going to do it the complementary way. So P pair not equals 1 minus the probability of a pair. 1 minus probability of a pair. So I'm going to actually change my color here. The pairs, I'm going to circle 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. I have 1 2 3 4 5 6. 6 out of 36. I'm going to change the color here so you can still see that properly. I have 6 outcomes where I roll a pair. Therefore, the probability of me not rolling a pair would be 36 over 36 minus 6 over 36, which is equal to 30 over 36. And let's reduce that to 5 6. So I hope that lesson was clear. And if you have any questions, just let me know. And that's it for lesson 4.